This is Sam Daulton. I'll be presenting our work on Distilled Thompson Sampling via Imitation learning. This is joint work with Namkoong and Eytan Bakshy. A contextual bandit problem is a sequential decision-making problem where at each time step, the policy receives a set of contextual features. Given those features, the policy decides an action to take. That action is performed and conditional upon the context and the action, a reward is received. Thompson sampling is a popular algorithm for contextual bandit problems. Thompson sampling selects actions with probability proportional to an action being optimal. These two steps, posterior sampling and numerical optimization, are both computationally intensive. This high computation cost poses practical challenges in low latency applications where high latency degrades the user experience. This problem is exacerbated on slow processing units on older phones. An additional challenge is on-device deployment, where devices often have limited memory and model size becomes a critical concern. To address these practical challenges, we propose to distill a Thompson sampling policy via imitation learning. Given a probabilistic model with an implicit Thompson sampling policy, we propose to learn an explicit policy representation. This explicit policy can be used for fast online decision-making while retaining a principled exploration strategy. Importantly, our imitation learning algorithm shifts the heavy computation involved in posterior sampling and numerical optimization from the online setting to the offline setting. The explicit imitation policy can then be deployed in the online setting for fast online decision-making. New observations that are collected under the imitation policy can be passed back to the Thompson sampling policy for offline batch posterior updates. We find that our imitation learning algorithm enjoys the same Bayes regret as the best UCB algorithm up to a sum of single time step imitation errors. Importantly, these errors can be easily controlled in the presence of abundant unlabeled context. Empirically, we find that there is no difference between the imitation policy and the Thompson sampling policy in terms of cumulative reward. Our wall time measurements show that our imitation learning algorithm reduces decision-making latency by over an order of magnitude. For more details on our work and further results, please check out our oral presentation and our paper. Thank you.